We're counting down the 5 most shocking factory accidents ever captured on security cameras. From routine handling slips to full-scale industrial disasters, each incident exposes a critical engineering flaw and the simple checks that could have stopped catastrophe. Which hidden failure tops the list as the most preventable tragedy? Let's begin with number 5. August 3rd, 2020, Samut Prahan, Thailand. A steel coil, several tons of tightly wound metal, hangs from an overhead crane. The operator readies the lift and trusts the slings to hold steady. But the rigging is already at risk. The sling angle stretches wide, reducing safe capacity by more than half. According to ANSI and OSHA standards, any angle greater than 60 degrees can turn a certified sling into a hidden hazard. No proof load certificate is visible, and the daily inspection checklist is missing from the work area. In seconds, the coil slips free and crashes to the floor, narrowly missing a worker. The aftermath reveals worn rigging that should have been retired, and no signed checklist confirming pre-lift checks. A crane safety inspector explains that misrigging and likely exceeded hoist capacity could have been stopped by daily pre-lift checks and proof load certificates. Routine inspection, load verification, and a simple checklist could have prevented the drop. Molten metal waits at over 1,600 degrees Celsius. A load of scrap is charged into the furnace. Hidden inside, a trace of water, barely a teaspoon, meets the liquid steel. In less than a second, that water expands more than 1,600 times, turning into a violent burst of steam. The blast hurls molten metal across the foundry floor, sending a white flash through the air and peppering nearby equipment with burning droplets. Operators scramble for cover. The explosion is over in moments, but the damage is done. This kind of wet charge incident is preventable. Industry standards require scrap to be stored under cover for at least 24 hours before charging, keeping rain and condensation at bay. Moisture meters, standard tools in modern foundries, check every load before it enters the furnace. If weather threatens, charging is suspended until scrap is dry. A foundry process safety manager puts it bluntly. A teaspoon of water in molten metal becomes an explosive volume of steam. Pre-charge moisture meters are non-negotiable. Simple protocols such as covered storage, drying periods, and mandatory moisture checks turn a potential disaster into just another routine shift. A sudden roar shakes the furnace hall. The roof of a metallurgical furnace gives way and launches a burst of molten metal and fire into the air. Inside, the temperature climbs past 5,000 degrees Fahrenheit, hot enough to vaporize steel. 2 workers, just outside the main enclosure, scramble to safety as the pressure wave rattles the building. Later inspection reveals the warning signs, a patch of spalled refractory lining, visible but left unchecked. Over time, the protective barrier had thinned, exposing the steel shell to direct heat and oxygen. As the lining failed, oxygen seeped in, fueling a runaway reaction. Without burner interlocks or active oxygen sensors, the system kept feeding fuel. Pressure built until the weakest point, an unvented door seam, gave out. According to NFPA 86, regular refractory inspection and automated burner shutdowns are mandatory. Thermographic mapping could have spotted the hotspot days earlier. A furnace design engineer explains that refractory failure plus oxygen ingress produced a pressure pulse. Automated burner interlocks and relief paths are the fix. Scheduled inspections and interlocks turn a near disaster into a contained event. A container ship edges toward its berth, guided by tugs and mooring lines. But as the vessel swings closer, a sudden gust of wind catches the bow, pushing the ship off course. The fender system, meant to absorb the impact, buckles under the load, unable to dissipate the full kinetic energy. Within seconds, the hull scrapes the quay, and the vessel's mass transfers directly into the legs of a nearby gantry crane. The structure shudders, then collapses, bringing down thousands of tons of steel and machinery in a tangled heap. Port operations grind to a halt. The loss runs into the tens of millions, with a single collision triggering weeks of downtime and global supply chain delays. Industry standards like PNT's Fender Energy Guidelines set strict requirements for berth protection, accounting for vessel size, berthing velocity, and environmental factors. But in this case, the fendering was undersized for the ship's displacement and approach speed. Exclusion zones, meant to keep cranes clear during berthing, were not enforced, and no live telemetry alerted operators to rising mooring loads as the weather changed. A port operations engineer explains, insufficient fendering and no operational exclusion zone allowed the ship to reach the crane. Design redundancy and berth controls are required. Port authorities now mandate enhanced fender systems, real-time wind and current monitoring, and automated exclusion zones for crane placement. The lesson? Infrastructure must be designed for the worst-case scenario, not just the routine. When a single mistake can topple an entire terminal, engineering and operational safeguards are the only buffer between routine docking and disaster. A boiler room at Tampa Electric hums with the routine of a maintenance shift. Contractors move into work on a slag tank, even as the boiler stays online. Inside the pressure system, corrosion has thinned the steel walls, erosion that ultrasonic thickness mapping could have revealed months earlier. The relief valve, designed as the last line of defense, sits untested, stuck in place by years of mineral buildup. The annual ASME-B Beef C. Section 1, test required by code, never happened. On this day, a sudden surge pushes the system past its limit. Pressure spikes with nowhere to go. The relief valve fails to open. In seconds, the slag pot erupts, launching molten metal and equipment through the containment area. 3 workers, Antonio Navarrete, Armando Pitis, and Frank Jones, lose their lives. 1 survivor is left with life-changing injuries. OSHA investigators uncover missing test records, lapses in contractor integration, and a hot work permit system that broke down. The company faces $130,000 in fines and a 5-year legal battle, ending in a public admission of willful safety violations. A mechanical engineer says failed relief valves and undetected thinning allowed overpressure, and that mandatory relief testing and wall thickness mapping would have prevented this blast. Annual relief valve testing, routine ultrasonic thickness checks, and strict hot work permit rules form the backbone of modern boiler safety. Without them, a single missed inspection can become a tragedy. Across all 5 disasters, one fact stands out. Unseen engineering flaws trigger the worst accidents. In factories, what is overlooked is what endangers lives. Vigilance is everything.